Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed about the Pascal's law. Today, we are going to see the mathematical relation that we can derive using the Pascal's law, and we will be seeing some of the applications of the Pascal's law in our daily life or in our practical life. Okay, so with that, let us begin our lecture. Please take out your copy and pen, and please do start writing, as writing is an important part of your study. Don't forget to write, read and write. Okay, so if I just want to recapitulate the Pascal's law, I think you all have remembered the Pascal's law. The Pascal's law is something like that if there is a confined liquid and if we apply any pressure at any point in the confined liquid, certain amount of pressure at any point in the confined liquid, then that pressure is being transmitted through that liquid in all directions in undiminished manner. That is, the pressure does not decrease, does not increase or does not decrease. It is transmitted undiminished throughout the liquid. So this is basically the Pascal's law that we have been talking of. Now, using this Pascal's law, so just let me draw a figure. You can just have a brief idea about the Pascal's law, how it is being applied in our daily life. Okay, so say if there is a section like this. Okay, there is a section like this. There is a pipe which is having a fluid, and a fluid is running through the pipe, and this section have a larger area, and here there is a smaller area. Okay, fine. Now there is a fluid running through this pipe and this entire part. Okay, this is fluid field. Okay, so this is fluid field. Now say if I consider that the area of this particular part 1 is A1, and here the area is A2. Okay, and we apply thrust here of F1, and as a result of this application of thrust, a thrust here is obtained as F2. Okay, fine. Now what happens that as you know, when you apply a certain thrust on a certain area, you can say that pressure is being applied. So if I consider that here the pressure being applied is P1, if the pressure here applied is being P1, and if we get due to this pressure applied here, we get an upward pressure here as P2. Okay, now Pascal's law says that this pressure P1 definitely must be equal to pressure P2, isn't it? Pascal's law states this. Okay, so if P1 is equals to P2, can we say that this pressure P1 is equal to F1 by A1? So this is F1 by A1, this is F2 by A2. Now if I just take out the consider the ratios of the areas and the forces, so I can say that F1 by F2 will be equals to A1 by A2, isn't it? A1 by A2. Fine. Now if we see here that the area A2 is greater than A1, so if I say that area A2 is greater than A1, so according to the figure, if area A1 is greater than A2, A1 is greater than A2, then definitely this ratio will be greater than 1, and if this ratio is greater than 1, then we can definitely say that this particular ratio will also be greater than 1. So if area A1 is greater than F2, then definitely we can say that the force F1 is greater than force F2. So what does this mean? This means that if we apply a less amount of force on this particular, say just reverse the direction of the arrows. Okay, we are applying the force here and we are getting the force output here. Okay, thrust output here. So if I apply a less amount of force F2, thrust F2, then we will get a greater amount of thrust on this other area, on the larger area. So basically this is the utility. What does the Pascal's law actually says that the thrust is being multiplied when applied to a certain liquid, and if there is a greater area and smaller area, then the thrust applied can also be magnified, can also be amplified. Okay, so this is basically the very basic application of the Pascal's law. Okay, and based on this very basic application, actually we there are three applications of Pascal's law. Basically this concept or this principle that we have demonstrated here is called the principle of hydraulic machines. Okay, so this is the basically application of Pascal's law, principle of hydraulics machine, principle of hydraulic machines. Okay, these are this kind of machines that uses this kind of principle is known as hydraulic machines. Okay, so this is the application of the Pascal's law. We are applying the Pascal's law in order to design such machines. Okay, now these hydraulic machines, as we have in our syllabus, there are three hydraulic machines that are being discussed. One is the Brahma's press or hydraulic press. Second is the second one is the hydraulic brake, that the brakes that are present in your vehicles, okay, cars or trucks, buses, okay, and the third application is the hydraulic jack or the hydraulic lift that you can say. Okay, so all these three instruments, all these three devices work on this very basic principle of hydraulic machine. Okay, so all these are hydraulic machines. Okay, so I think the concept is clear. Now just let us briefly discuss the concept of hydraulic. First of all, let us consider the concept of hydraulic press. Okay, hydraulic press. So let us see hydraulic press. Okay, so what happens in hydraulic press? Basically, we use this technique to press certain things like we can press a large amount of cotton into very small volume. Okay, we can press a bundle of paper into a very thin volume. Okay, so these are the applications that you can use that you can do with the help of a hydraulic press. Okay, so how is the construction of a hydraulic press? Okay, so make a heading hydraulic press, hydraulic press. Okay, fine. Now what is this hydraulic press? Okay, so if we draw the figure, there are basically two cylinders. Okay, there are basically two cylinders. One cylinder is used for applying the thrust, and another cylinder is used for pressing the materials. Okay, pressing the materials. So one cylinder is here like this. Okay. Fine. This is one part of the cylinder. Okay. So there is basically piston-like arrangement. Okay, piston-like arrangement here. Fine. Below is liquid fluid field. Okay. So another cylinder is up here. Okay. Here is also a piston-like arrangement used. Okay. And now these two cylinders are joined. Okay, so let us consider that okay, these are joined like this, so these are connected, interconnected. Okay, this pipe goes into the reservoir like this. Okay, there is a reservoir here. This pipe basically pulls up the water from here, or the liquid that is being used. Okay, and on the other hand, okay, there will be another connection from here like this. This goes like this. Just lower it a little bit. It releases back the liquid here. Okay, it releases back the liquid here. Okay, fine. Like this. There is a valve situated here. Okay, there is a valve situated here. Here is another valve that will move up and not down. Here is a valve that will move up and not down. Okay, fine. Here is the structure. Here is its support. A plate-like structure on which the materials are placed. Sorry, materials are pressed. Okay, like this. Fine. Here the materials get pressed. Okay. Fine. And there is a lever-like arrangement like this. A handle is being attached here. Okay. So it's something like this. Here it is attached. The handle. You can actually just move up and down the handle here. Okay. Fine. Okay. So this is the arrangement. Now, what happens here? See. This one is a valve V1 and this one is a valve V2. Okay. Initially this valve is locked. Okay. Initially this valve is locked here. Fine. Initially this valve is locked here. Okay. It's locked. So, okay. And here is the fluid present here. Here is the fluid here. Here is the fluid. Here is the fluid. Here is fluid. Okay. So I was just explaining it. Okay. See what happens. So in the beginning when the process begins, here there is no liquid. Here there is no liquid. Okay. Here there is no liquid. This entire space is empty. The reservoir has liquid filled in it. Okay. What happens when we just move this piston up? Just try to understand this concept. When we move this piston up, okay. Say we are moving this piston up. What happens here? A vacuum is being created here, or the pressure at this region is lowered. Okay. Here atmospheric pressure acts on this free surface of the liquid. This atmospheric pressure basically pushes the liquid up when you actually move this piston up. So due to the atmospheric pressure, the liquid starts moving up into this space here. So this space gets filled up with the liquid. Okay. This space gets filled up with the liquid here. Fine. Now, when you press the piston here, what happens? This piston when it comes down, say it moves down a little bit, it comes at this position. What happens? At this position when it comes down, okay, it presses the liquid. Okay, now what happens when it presses the liquid? It will not go down. Okay, it will rather escape through this region. It will come out through this pipe and will fill up this entire space here. Okay, now here the valve V1 can move only upward. So when you press the piston here, okay, what happens? It pushes the liquid up and the valve V1 moves upward and this entire space gets filled up with the liquid. Initially this valve V2 is actually locked. So the liquid just cannot flow out through this pipe. Okay, so initially it is locked. Fine, it is locked. So the liquid cannot flow out. So the liquid fills in here and it starts exerting, as we exert the pressure here, it starts exerting pressure on this piston P2. Say this is the piston P2. Okay, this is the piston, say P1. Okay, P2, and this is the piston P1. Okay, now when we just apply the thrust on the piston P1, what happens? It exerts a pressure on the piston P2 and this piston moves up. As the piston moves up, whatever thing that is being kept, just say we have kept a bale of cotton. Okay, now this bale of cotton will get pressed in between these two slabs. One slab is this and this is a fixed slab. Will get pressed. Okay, now when you just the liquid is being pressed and you need to lower down the piston P2, what happens? This valve will not allow the liquid to go back because it will open upward, not downward. So it gets closed here. Fine. When the liquid just gets up here, it gets closed. Okay, so when you push down the piston here, it will not be getting down. Okay, the liquid moves up and when this pressure here becomes less, it just closes down. Now when you when the bell of cotton is placed up here, we need to lower down the piston. What you do, you open this valve. Okay, you open this valve. Now what happens whenever you are opening this valve, actually the liquid starts flowing out through this region here. Liquid starts flowing out through this region here. Okay. Now when the liquid starts flowing out through the region here, the pressure here will get released and the liquid will be emptied here. The piston will slowly come down and this space will be again coming to the initial position, and the fluid again goes back to the reservoir. Okay, so it comes back to the reservoir. In this way, what happens? Actually, the principal the piston works. Okay, fine. And again, when you want to repeat the process, again you have to just move this handle up. When you move this handle up, again a vacuum region will be created here. Atmospheric pressure works on the fluid here. It will move the liquid up into the this space. Okay, and then when you press down the this bar, it creates a pressure. It thrust is being exerted. It creates a pressure, and that pressure moves the or just pushes the liquid into this pipe. This valve V1 moves up and the liquid fills up the space here and exerts the pressure on this piston P1. The piston, P2, and this piston P2 moves up. In this way, what happens? The hydraulic press or the Brahms press actually works. Okay, so I think the concept of hydraulic press is clear. Oh, sorry, it should be a little down like this. Okay, now I think it is clear. Fine. So the concept of hydraulic press or Brahms press is clear. So this very simple process is based on the Pascal's law. So I think the concept is clear. So like this, there are two other applications. One is the application of the hydraulic brake that you use in the cars. Okay, I think after understanding this concept here, you will be able to understand the concept that is used in the hydraulic brake. Please study in the book. If we have time or time permits, we will discuss the two more applications. That is, one is the hydraulic brake and the other one is the hydraulic lift. Okay, hydraulic lift I have demonstrated the first diagram. That diagram is basically of a hydraulic lift. Okay, so I think we will do this in some later class. In the next class, we will be moving on to the next part of the chapter. Okay, so with that we come to the end of today's lecture. Please, if you have any query, mention in the comment box. We will be happy to solve your problem. With that, we end our class. Thank you. Goodbye.